my channel Lazy Fellows. I am your PharmaBahen. Pharmaceutical Analytical Techniques is a subject of M.Pharmacy Pharmacological Department Semester 1 under the PCI. Now we are going to discuss about the unit 6 topics: paper electrophoresis, gel electrophoresis, capillary electrophoresis, zone electrophoresis, moving boundary, and isoelectric focusing. First of all, we have to know about the classification of the electrophoresis. And generally, there will be so many classifications, but I would prefer this one. Uh, the first is like free electrophoresis, no medium, solid medium used. Zone electrophoresis. In the free electrophoresis, we have moving boundary, micro electrophoresis, isoelectric focusing, and capillary electrophoresis. And in this zone, we have paper, cellulose acetate, gel, and starch gel, and immuno. In our syllabus, we have only the moving boundary, isoelectric, capillary, and paper, gel electrophoresis, and zone electrophoresis as a topics. Why I wanted to ask you people, like, why the capillary is under the zone electrophoresis? Answer me in the comments. I will be revealing the answer in the video ending. Okay, now let's go with the paper electrophoresis. Like in the paper electrophoresis, we will be discussing principle, instrumentation, working condition, factors affecting, and separation and applications. Okay, what is actually electrophoresis? What is actually electrophoresis means? Separation of charged particles like proteins and DNA under an applied electric field, and a medium for the supporting. And the paper electrophoresis, the supporting medium is the paper. Okay, under the electric field applied. So let's take this as an anode, this as a cathode, negatively charged electrode. When we place biomolecules with negatively charged, this negative will be traveling towards the positive electrode. When we place the positive sample biomolecules, it will be traveling towards the cathode. Okay, this is the criteria of separations. Okay, and the separation may depends upon what? The charge of the particles, how much the charge that possess the biomolecules possess, and the size, either small or big, it will also affect the thing. And the shape of the molecules, like of course, the fat, like round ones can pass to the capillaries, or else whatever the paper is there. But the thing, the irregular shaped one, or the rectangular shaped one, can have a difficulty in traveling. Then coming to pH, ionic strength of the buffer also affects the movement of the particles. Then coming to instrumentation, we have a power supply, DC voltage connected range 100 to 500 volts with the regulators. Then coming to electrophoresis chamber, this is the electrophoresis chamber where the buffer is placed in this chamber with the ends of paper. Paper ends are placed in the both the electrophoresis chambers. And supporting medium is what? Next, the supporting medium is the Wattsman filter paper number 1, and it provides the capillary action by providing uniform and hydrophilic nature for the biomolecules. And then sample application. The sample is not poured with the glass or anything. It is poured with the micropipette, because the quantity of the sample that we put on the paper is very mandatory. Yes, because that small part contains many of the biomolecules. Okay, then the visualization chamber. What is a visualization chamber? Like the paper is kept in some sort of solvents, so that the color changes will be appear, so we can see the bands of the biomolecules, how much they have traveled. According to that, they will get separated, and so that because of the dyes helps us recognize the biomolecules where the band present on the paper. Then the working conditions. Working conditions, we have to maintain the buffer at the pH where it is good for the conductivity. We use Bobbiton buffer normally. And the paper saturation. The paper must be pre-saturated with the solution and before the sample application. Then the sample volume. Typically 1 to 10 microliters is used. Voltage, we have to apply it for 1 to 4 hours duration. Detection, the papers can be dried with ninhydrin for amino acids identification. It gives the purple color. And the reducing sugar, we use aniline hydrothalate. Then the lipids, Sudan black will give the blue black color. And the purines and pyrimidines will give UV light. Under the UV light or 2,4 dinitrophenyl hydrazine, it gives the yellow color or the orange hydrogens. Now let's look for the working conditions. Here the anode is a positively charged and the cathode is a negatively charged electrode, and don't confuse it with the anions and cations. Anions are positively biomolecules, anions are negatively charged biomolecules, cations are positively charged biomolecules. The sample is placed, the paper is this, it is pre-saturated with the solution of the buffer, and the ends are placed in the chambers, electrolysis chamber, and the sample is placed right in the middle. So under an applied electric field, the sample will be moving towards the oppositely charged particles, oppositely charged electrodes. Anions will be moving towards the anode, and the cations will be moving towards the cathode. Okay, then the factors affecting electrophoresis. We have a pH of the buffer influences the charge of the molecules indirectly that affect the migration towards the anode or cathode, of course. Then the ionic charge of the strength of the buffer influence the conductivity and speed of the migration. Voltage applied, higher the voltage, higher will be the migration, of course. At temperature, higher the temperature, there will be higher denaturation, and paper dries faster. But this is a problem, so we have to maintain the optimum temperature for the electrophoresis, and this is allowed, but this is not allowed. Sample concentration, overloading can lead to sticking or poor resolution. I've told not we have to use micropipettes to the sample concentration, not concentration, the quantity I'm telling. The concentration should be very normal. Time of electrophoresis, insufficient excessive time carried to complete the process incorrectly. If time must be optimum, that's it. Applications, we have many users with the electrophoresis. We can use it for the separation of amino acids, hemoglobin variants, HbA, HbC, and separation of serum proteins, albumin, globulin. Clinical diagnosis, detect abnormal proteins. Purity check of biomolecules in the research. And advantages, it was a low cost and minimal instrumentation. And I have told you about this question, right? Why the capillary is under the zone electrophoresis, is not under the zone electrophoresis. Sorry, mistake. Not under the zone electrophoresis because the capillary electrophoresis is done with the silica gel. Silica gel is considered as a solid. So, because of this solid medium, it is placed in the free electrophoresis, not the zone. Thank you so much for watching the video, friends.